All right, in this video we're going to talk about the applications of right triangles. We see a lot of right triangles when working in geometry and different types of problems throughout there. Right triangles are very specific. Obviously, that's where we can get away with using SOHCAHTOA and a lot of the Pythagorean theorem style problems that we have just grown to know over the years. But when we start looking at applications of right triangles, it's going to require us to know angle of elevation and angle of depression. And if we haven't ever talked about that, they can be a little new and confusing to some people, but hopefully after this video, you'll feel comfortable with being able to decipher how they look in a problem. Angle of elevation comes from whenever the angle is coming off the ground. So this is our ground here, and as the angle of maybe someone looking up at a building or a tree increases, the angle comes off the ground, giving us our theta. Okay, angle of depression is similar. However, from what I've seen most of the time, angle of depression comes as if someone is on top of a tower and they're looking off into the distance. This is the horizontal sight line. That's the sky. It's the horizon, right? Well, the depression is if I see something down here and I'm looking down, my angle of depression comes off the skyline, forming with whatever I'm looking down at. Now, this doesn't help me at all if I'm trying to figure out maybe the height of the tower, okay? So what happens is, notice, going back to our old geometry skills, I have two parallel lines, and this is a transversal. All right, if you need a review on that, check out the video of parallel lines cut by a transversal, and the different angles are in there. However, for this video, I know that this angle and this angle are congruent because they are alternate interior angles. Okay, so that's how angle of depression can help me by figuring out how to draw my right triangle. So angle of elevation, angle of depression, very useful to know. Remember, SOHCAHTOA, extremely helpful. It helps us remember our ratios for the right triangles. Sine deals with opposite and hypotenuse. Cosine deals with the adjacent side and hypotenuse. And tangent deals with the opposite and the adjacent sides. Okay, so let's check out our first problem here, and let's draw the picture and solve. A ladder leans against a house where the base of the ladder is 14 feet from the base of the house. The ladder creates a 46-degree angle of elevation against the ground. How long is the ladder? Well, we have our house. I know that there is a ladder leaning against the side of the house, and the base of the ladder is 14 feet from the house. We also know that the ladder creates a 46-degree angle of elevation with the home, and we want to know how long is the ladder. So what I need to do is I need to think back to my SOHCAHTOA, and I need to determine which trig ratio I am currently working with. So we have sine, we have cosine, or we have tangent. So I have, when I look at my theta here, I have my adjacent side and I have my hypotenuse. So the only one that deals with adjacent and hypotenuse is cosine. So we set up our problem by saying cosine of whatever your angle measure is equals our adjacent side over our hypotenuse. And now we are going to simply solve for x. So multiply both sides by x. That's going to cancel, giving me x times cosine of 46 equals 14. And then I'm going to divide both sides by the cosine of 46. Once I divide both these sides by the cosine of 46, we wind up with x equals 20.15 feet. So our ladder is 20.15 feet long. Application of the right triangles, not too bad. Again, look for wherever your theta is. determine your trig ratio, and then solve for x. So let's look at another one. So we have a balloon that is tied to a mailbox which stands 4 feet off the ground. If the balloon string is 38 feet long and the wind blows the balloon so that the string forms a 72-degree angle of elevation, find the height of the balloon. Now, this is a very interesting problem because we also have to account for this space here. So when I find the value of x, I'm not quite done with my problem. But in the meantime, let's check out SOHCAHTOA and let's determine which trig function we're going to be using for this problem. Here's my theta measurement. I have the opposite side and I have the hypotenuse. So that's going to be sine. So we say the sine of 72 equals my my opposite side over my hypotenuse. Now I'm just going to solve for x, multiply both sides by 38. I wind up with x equals 38 times the sine of 72. When I plug that in my calculator, I get x equals 36.14 feet. Now, I'm not done because we know that x equals 34.1 or 36.14, but I have to include that there's this 4 feet down here. So the balloon itself is 40 feet and 40.14 feet off the ground. All right. So again, make sure we're answering the whole question. Make sure we're utilizing all of the information given to use these trig functions, these trig ratios, to solve these right triangles. Let's look at one last problem. You're standing watch over your castle in a high tower. Your tower stands 200 feet above the ground. So we have 200 feet here. You notice a small army is approaching some distance from your castle. Boop, small army. You spot them with a 38-degree angle of depression. So remember, our angle of depression is that horizontal sight line coming down. So this is our theta here, and that's going to equal 38 degrees. Well, going back to what we learned in the beginning of the video, I know that I can call these two corresponding angles because it's two parallel lines, this parallel line and this parallel line, cut by that transversal. So 38 degrees is here. How far away is the army from your castle? Well, I want to know the distance, x. I'm given 38 degrees is my theta, and we know the height of my tower is 200 feet. So we have the opposite side and the adjacent side. So when I'm looking at SOHCAHTOA, I know that the only one that deals with the opposite and the adjacent is tangent. So I have the tangent of 38 equals 200 times x. 200 divided by x. Multiply both sides by x. X times the tangent of 38 equals 200. Divide both sides by the tangent of 38. And we get x equals 255.98 feet. Now, in the grand scheme of mathematics, if that's how far away that army is from you, you're in trouble. So I hope these videos really helped you guys understand right triangles and their applications and how to solve them. Thanks for checking out the video, and please check back to see more as we move forward in triangles.